The process of cloud formation and precipitation begins with sun's radiant energy warming the Earth's surface. This heat energizes water bodies like oceans, lakes, rivers, and even moist soil, causing water molecules to gain enough energy to escape into the air as vapor. This invisible vapor marks the first step in cloud formation, setting the stage for a vital atmospheric journey. As the sun continues to shine, water evaporates steadily. The vapor rises upward into the atmosphere, carried by warm air currents. The more intense the sunlight, the greater the evaporation rate, especially in tropical or coastal regions where heat and humidity are abundant. As the water vapor ascends, it encounters cooler layers of the atmosphere. The higher it goes, the lower the temperature becomes. This cooling is essential because it prepares the vapor for condensation, the transformation of invisible gas back into tiny liquid droplets. When the vapor cools sufficiently, it begins to condense. But condensation needs a surface to clinch to. Tiny particles floating in the air, like dust, smoke, or pollen, act as condensation nuclei. Around these particles, water vapor condenses into microscopic droplets, forming the building blocks of clouds. These droplets gather and cluster, creating visible clouds. Depending on altitude, temperature, and moisture content, cloud can take various forms: wispy cirrus, fluffy cumulus, or thick, dark nimbostratus. Each type of cloud tells a story about the weather to come, from fair skies to impending storms. As more vapor condenses, the cloud becomes saturated with moisture. The droplets multiply and grow, making the cloud heavier and darker. This saturation signals that precipitation may soon occur, especially if the cloud continues to accumulate moisture from rising air currents. Inside the cloud, droplets collide and merge, forming larger drops. In colder regions or higher altitudes, these may freeze into ice crystals, the process of coalescence, where droplets stick together, is crucial for forming precipitation-sized particles capable of falling to Earth. When these droplets or ice crystals become too heavy to remain suspended in the cloud, gravity takes over. They begin to fall toward the Earth. This descent marks the beginning of precipitation, which can vary in form depending on temperature and atmospheric conditions. If the air below the cloud is warm, the falling moisture reaches the ground as rain. If it's cold, it may fall as snow, sleet, or hail. Each type of precipitation has its own formation process and environmental impact, from nourishing crops and refilling reservoirs to causing floods or frost. Once precipitation reaches the ground, it replenishes rivers, lakes, and groundwater. Some of it evaporates again and continuing the cycle. This endless loop, evaporation, condensation, and precipitation, is known as the water cycle, and it's vital for sustaining ecosystems, agriculture, and all forms of life on Earth.